Hi dear students and viewers, welcome back to our channel and Vinay Kumar Basics of Physics. Dear students, in our channel there are so many videos regarding the inter first year physics, inter second year physics. So if you want to watch the any particular video of particular chapter, then go to my playlist and check the playlist. All the playlists are available with concerned chapter name. మన ఛానల్లో చాలా చాప్టర్ సంబంధించినటువంటి వీడియోస్ ఉన్నాయి. మీకు ఏదైనా పర్టికులర్ టాపిక్ కావాలనుకున్నప్పుడు ఆ టాపిక్ అనేది ఏ చాప్టర్లో తెలుసుకుంటే ఆ చాప్టర్ నేమ్తో ప్లేలిస్ట్లో చెక్ చేసుకోండి. దాంట్లో వీడియోస్ ఉంటాయి. ఒకవేళ ప్లేలిస్ట్లో ఏదైనా వీడియో దొరకకపోతే నాకు ఏదైనా ఒక వీడియో కామెంట్ చేయండి. నేను వీలైనంత త్వరగా వీడియోని అప్లోడ్ చేస్తాను. ఓకేనా? సో లేట్ చేయకుండా వెళ్ళిపోదాం. In this video, I am going to explain about one of the most important topic. What is a transistor and how many types of transistors are there, and what is the working of PNP transistor and how the NPN transistor can be works. So the complete information I am going to give in this video. That's why we have to watch the video up to last without any skip. So the configurations of transistor we will discuss in the next video, but in this video only what is the transistor and how many types are there, how they can work. Let's go for that. Here children, transistor, what is mean by transistor? Transistor is nothing but transistor can be written as like this, simply here transfer of resistance. Transfer of resistance. That means a transistor is a device that should be sends the current from low resistance to the high resistance circuits. Transistor is a device that can sends the current from low resistance to the high resistance near circuit. So how the transistor will be there? How many parts are there? In a transistor, there are three main parts are there. One is the emitter. There are three main parts in a transistor: emitter, base, collector. Clear? So what is emitter and what is the base and what is the collector? How they are in a transistor? First thing, how the transistor can be formed. When we are taken particular type of semiconductors, in between the same type of conductors another connector should be sandwiched. Here 1 2 3, what I am going to say, 1 and 2 are belongs to the same type of semiconductors. In between them another type of semiconductor is attached or sandwiched or connected or inserted. Then a transistor can be formed. Clear? When one particular type of semiconductor should be sandwiched between two of same type of semiconductors, then a transistor can be formed. Clear? So to understand it simply here, we are going to say now, to understand that here the order of the parts in a transistor should be like this. This is the first part and this is the second one. This is called emitter and this is the base and this is the collector. The order is E, B, C. What is E, B, C? Clear? First one is what? Emitter. Next one is what? Base. And this one is what? Last one is what? Collector. So emitter, base, collector. Here what I am going to say, emitter and collector are the made up of same type of semiconductors. But the base, what it is there, that is the different from the E and C. B is the another semiconductor. Clear? So the base is the very thin, very thin, and that should be lightly doped. Base is what? Thin and lightly doped region. In a transistor, the region which is very thin and that should be lightly doped, that should be what we call base. Thin and lightly doped. And in a transistor which is having the heavily doped or strongly highly doped region, what it is called? Emitter. And in transistor, collector is the moderately doped. It means doping of collector should be less than the doping of emitter, and that should be more than the doping of base. Clear? So this is simply how we can identify the emitter, base, collector in a transistor. Emitter, base, collector, this is the order. And emitter is heavily doped and base is lightly doped and collector is heavily doped. Clear? Here what is the work of emitter? Emitter can emits means what? Sends. It can emits the charges into the base. Emitter is nothing but a source. Here it can sense the charges from emitter to the base. And what is the work of collector? Work of collector is nothing but here collector. It will collect the charges which are coming from the emitter to base. Clear? That is simply about the emitter, base, collector. Clear? What is the emitter? Which is a highly doped region and there should be emits the charges to the base. And what is the base? It is the very thin region and lightly doped, and there should be sends the charges from emitter to the collector. And what is the collector? It is the moderately doped. What is moderately doped? And it will collect the charges which are coming from the emitter via base. Clear? So this is simply order of the emitter, base, collector in a transistor and what their purpose. And now look here children, there is one line, it is there here, this is the one line that should be called as here emitter base junction. This is what children? Emitter base junction. What is emitter base junction? And this is what we call children, it is base collector junction. What is base collector junction? On that time we discussed in case of PN junction diode, it is the trivalent impurity is there in that one, that is what we call P type material, and this is the N type material, and this is the region that should be here combined state P and N. Now this is what we call PN junction, and there is some here, there it is there, that is what we call depletion layer, So clear? Like that here, this line is what? Emitter base junction, and this line is what? Base collector junction. Emitter base junction always should be given in forward bias. Emitter base junction is always given in forward bias, and base collector junction is always should be given in reverse bias. You have to remember that. While a transistor should be given to any circuit or any battery, how we can write? Emitter base junction is always should be in forward bias and base collector junction should be always in reverse bias. You have to remember that. Clear? This is simply about the what is transistor and what are the parts in a transistor and what are the purpose of the those parts in the transistor, and what is mean by emitter base junction and what is mean by base collector junction, and how the emitter base junction is connected, how the base collector junction is connected. Simply this is about the transistor. Now how many types of transistors are there? Let's discuss. Dear students, transistors are divided into two types. They are mainly here PNP transistor. What is PNP transistor? And next one is the NPN transistor. NPN. First one is PNP and next one is NPN transistor. So just now only we discussed children what is the order of the emitter base collector in a transistor? You have to observe this one. What it is? Emitter, base, and this is the collector. Now we can compare like this. For PNP transistor, like this. This is the P, and this is the P, and this is the N, and this is the P. Clear? PNP transistor. So look here. PNP. You can compare now EBC and PNP. In a PNP transistor, emitter is P-type semiconductor and base is N-type semiconductor, and P is the collector is what? P-type semiconductor. P-type semiconductor. Emitter, base, and collector, like that. So in a PNP transistor, you can observe N-type material is sandwiched between the two P-type semiconductors. P-type semiconductors. Clear? So children, now it is the what we call emitter base junction, and this is what we call base collector junction. Base collector junction. Children, already we have idea about the PN junction diode. This is the P and this is the N. So here there is some reason it is there, what we call depletion layer. Depletion layer. What you observe there, in case of depletion layer, here positive charge will be created in the N-side material and negative charge will be generated here like this. Clear? So obviously it is a P-type material, PN junction diode, or P-type and N-type. In N-type positive charge is created, in P-type negative charge is created. That's why here holes are repelled by this positive charge and electrons repelled by this negative charge. That's why here some depletion layer is created and some barrier potential also available, like that. In this case also here, for a transistor, how many PN junction is there here? This is the first PN junction and this is the second PN junction. That's why here, in case of either it is PNP or NPN transistor, there are two PN junctions are available. And when it is not given to any battery, at every junction there is some depletion layer it is there. And what you have to say is, at PN junction what it is, depletion layer is there and barrier potential also there. The same thing will be happen in these junctions also, when it is ready to give any battery, like that. Clear? So now how the PN junction or how the PNP transistor should be connected to a battery in that way. How we can identify that? Let's see here. Very simple. Already we discussed what it is. Either it is PNP or NPN. The emitter base junction is always given to the what it is. Yes, this is the PNP. This is what, children? Emitter base junction. This is what? Emitter base junction. Emitter base junction is always given in forward bias. That's why here this is a PN type. Already we know, in case of PN, P is given to positive and N is given to negative. Then the red is what you have said, it is in forward bias, like this. And if P is given to negative and N is given to positive, then the diode is said to be in reverse bias. So that's why here simply what I am going to say here, P is given to positive and N is given to negative. Clear? Then the emitter base junction, first one it should be in forward bias. Clear? And now this is what? Base collector junction. Base collector junction always should be in reverse bias. Always in reverse bias. It means that the P should be given to minus and N should be given to positive. N is given to positive, P is given to negative. Then emitter base junction, base collector junction is in reverse bias. Reverse bias. So starting of the video, I told you what is a transistor means transfer of resistance. Transfer of resistance from transfer of current from low resistance to the high resistance. So here what it is, this one is what? Yes, what it is? Emitter base junction. How it is in forward bias? In forward bias, resistance is almost all zero. It means that what? Low resistance, low resistance. And this base collector junction, it is in reverse bias. It is in reverse bias. The resistance is more or infinity or high. That's why when the PNP tranche is given to any battery like this, then the current is moving from lower resistance to the higher resistance. Lower resistance to the higher resistance. That is simply what we discussed now up to now. Transfer of current from low resistance to the high resistance. So this is the simply what about the PNP. In PNP, P is the emitter, collector is the P type, and base is the N type. Emitter base junction is always to be in forward bias. For that, P is given to positive and N is given to negative. And base collector junction must be given to the reverse bias. That's why P is given to the P is given to negative and N is given to positive. Clear? So this is simply how the PNP transistor can be corrected in a circuit with a battery. That's simple. So we are not discussing about the bias of the PNP transistor just now. Children, the most important here, circuit symbols of PNP and NPN transistors. So this is simply about the PNP transistor. Then what about the NPN transistor? PNP is over. Now it is what? NPN. This is the N and this is the P and this is the N. That means in case of NPN transistor, a P-type material should be fixed in between the two N-type materials, or P-type material is sandwiched between the two N-type semiconductors. Then it is what we call NPN transistor. NPN transistor. Again, N is the emitter, P is the base, and N is the collector. Clear? In NPN transistor, what is N-type material? What is emitter? N-type material. And what is collector? N-type material. And what is the base? P-type material. So the transistor, whatever it may be, the emitter base junction is always should be considered in forward bias, and base collector junction is in always reverse bias. That's why here how we can write? P should be given to positive and N should be given to negative. Now it is in forward bias, and base collector junction should be like this. It is reverse bias. What is P is negative and N is positive. So in this way, a PNP transistor, a NPN transistor should be connected with a battery. Clear? So this is simply how the connections are in PNP and NPN. So children, there is two marks most important question. Draw the circuit symbols of PNP transistor and NPN transistors. Most important for 2 marks in IPE, Intermediate Public Examinations. How we can identify the PNP transistor and NPN transistor in circuits. For that, simply children, it is now. So it is a common base, and should be like this. So this is the base, and this is the collector, and this is the emitter. Clear? So if the arrow mark is outward, and here there is, I am going to draw one more thing here, one more transistor. So like this, again base, collector and emitter. If arrow mark is outward, that is the NPN transistor. If arrow mark is inside, that is the PNP transistor, and you can draw like this also. This is the base. Now it is, you can draw like this also. Most important for 2 marks questions in public examinations, draw the circuit symbol of PNP and NPN. If arrow mark is inward, that is PNP transistor. If arrow mark is outward, that is the NPN transistor. NPN transistor. So you can observe this one. So let's discuss about the working of PNP transistor. So very simple and very interesting concept, children. Watch very carefully. Working of PNP transistor. I already just now we discussed. This is the emitter and this is the base and this is the collector. This is the common base configuration. And now it is the arrow mark is inward. This is the circuit symbol of PNP transistor. Clear? And now children, here you have to observe, this is the PNP transistor, this is what emitter, and this is what base, and this is what collector. Emitter base junction must be given in forward bias. That's why P is given to positive and N is given to negative. That's why this emitter base junction is in forward bias. It is clear. And this is the base collector junction, that should be given in reverse bias. That's why here P is given to negative and N is given to positive. In a battery, this is the positive and this is the negative. Clear? So now this is the arrangement of the PNP transistors, very clear. Dear students, this is the battery between the emitter and base. That's why here the voltage should be taken as it is now VBE. That is nothing but input voltage. And now here it is the base collector. Now it is VBC. VBC. VB is the here now and VBC is there. Clear? This is the voltage between the base and collector. So now let's check what happened in this case. Very simple. What we discussed in case of PN junction diode forward bias, the same thing will be happening here. It is the positive charge and holes are the majority in p-type. The positive charge should be supplied to the p-type material, that is to the nothing but emitter. Clear? So I already told you, in case of emitter there are heavily doped. That's why so many number of holes are there. These holes are repelled by the positive charge of this battery. Then they must be enter into the base. In that holes, only 5% of holes should be combined with the electrons which are in the n-type material. Because holes are the positive and electrons are the negative. Holes are positive and electrons are negative. They want to combine each other because they are the unlike charges. So they want to become neutral. That's why here among the, for example, we are saying now 100 holes are moving from emitter to the base. In that only 5 holes are combined with the electrons and remaining are enter into the collector. So what we know, the moving of charges is what we call electric current. That's why here when the holes are moving in the emitter current should be taken as here IE. Clear? Got my point? Moving of charges is what we call electric current. The holes are moving. They are in motion. Why? Because repulsion between the holes in the p-type to the and positive charge of the battery. Due to that repulsion, the holes are moving and they should be moved towards the base. That's why while they are in motion, the current should be taken as in the emitter one is IE. And in that base already what I told you, it is very lightly doped. Even though it is n-type material, the concentration of electrons is less because it is lightly doped. That's why only few number of holes are combined with the electrons and remaining are enter into the collector. That's why here what I am going to say here, when the holes are moving in the base, the current should be taken as IB, and when the same holes are moving in collector, the current should be taken as IC. That's why here in this case what to write, IE is equals to IB plus IC. What is IE is equals to what? IB plus IC. Why? Because the holes which are in emitter, they are, for example, we are taken nowadays 100 holes are moving in the emitter, and in that here 5 are combined, and remaining holes are there in collector. That's why here 100 is equal to simply 5 plus 95, like that. It's simply, you have to remember, emitter current must be equal to the sum of the currents of base and collector. And in this case, what I am going to say here, IE is greater than IC, and IE is greater than also IB. Clear? So this is the, what you have to say, inside the PNP transistor the current is because of holes. Very simple. Due to the repulsion between the positive charge and holes, the holes are moving in the emitter and they should be entered into the base. In among that, only 5% of holes are combined with the electrons, and remaining holes are entered into the collector. That's happening. That's why in case of PNP transistor, inside the transistor the current is because of holes only. Then now we discuss what's happened in external circuit. So here, when the emitter base junction is in forward bias, here the negative term is given to what? N-type material. In emitter base junction, N-type is here base. That's why here the electrons must be coming from the negative terminal of the battery, and they should be entered into the base. That's why here there is some repulsion. There is some repulsion between the electrons which are in the base and the electrons which are coming from the negative terminal of the battery. Due to that repulsion, what do you have to say? The electrons are moving from base to the emitter. Again, those electrons are, again, they should be attracted by the positive terminal of the battery. Positive terminal of the battery. Clear? So what's happened, children? When emitter base junction is given to the battery like this, simply holes are moving from emitter to the base and electrons are moving from base to the emitter. And obviously here we discuss now what it is. The maximum number of holes are coming from emitter to the collector. Already here it is moderately doped, and some excess holes are coming from the emitter to the collector. These excess holes must be balanced by the electrons which are coming from this battery. Clear? So already in collector some holes are there. In addition to that, some holes are coming. For example, here 50 are there. Just imagine. One hole is coming here like this. This is now 50 plus 1. This 1 is the excess hole. That excess hole which is coming from the emitter to the collector, that should be balanced by the electron which is coming from negative terminal of the battery like this. So, and the excess hole must be here neutralized or nullified. So that's why what you have to say, in PNP transistor, inside the transistor the current is because of holes, and in case of PNP transistor, in outside circuit the current is due to the electrons. Clear? Very simple. The electrons are entered into the base and those electrons are repelled and they should be attracted by the positive of the battery. Again, some of the electrons are moving from this to here. Why? Because this is a positive charge. And the excess holes which reaches the collector, they should be balanced by the electrons which are coming from the negative terminal of the second battery. This is simply about the working of PNP transistor, children. Now let's discuss NPN transistor. Let's go for that. Dear students, now let's discuss about the working of NPN transistor. As usual, this is the circuit symbol of NPN transistor. Look here, arrow mark is outward, and this is the common base configuration. So children, NPN transistor, this is what emitter, and this is what base, and this is what collector. Clear? Emitter, base, collector. So already we discussed emitter base junction is always in forward bias. Here NP, forward bias P must be given to positive and N should be given to negative. That's why it is in now forward bias, and this is the voltage between the emitter and base. Simply what write VAB or VB, whatever may be. Clear? And this is the base collector junction. What is base collector junction? And that should be given in reverse bias. That's why here P is given to minus and N is given to positive. Clear? So children, what we discussed in case of reverse bias in PN junction diode, the same thing here we are going to discuss. This is the P and it is reverse bias. What we discussed there, holes are the majority and those holes are attacked by the negative of the battery. In N type, electrons are the majority and these are attacked by the positive of the battery. Then they should be moved in opposite directions like that. In the same manner, here you can observe same thing will be there. In N type, which are the majority? Electrons are the majority, and this is the emitter, that is heavily doped or highly doped. That's why more number of electrons are there. More number of electrons are there. That's why here, and that should be given to negative. That should be given to negative. Clear? That's why these electrons are repelled by the negative of the battery. Negative of the battery. That's why they must be moved towards the base, and they should be entered into the base. In that 5% of electrons are combined with the holes which are the majority in p type. Clear? What do you know? For example, from emitter to base, 100 electrons are entered. In that, 5 electrons are combined with the holes which are in the p-type material. In p-type material, holes are the majority. And remaining 95% of electrons are enter into the collector. Enter into the collector. Clear? So that's why here, what you have to say? The moving of charge is what we call current. That's why when the electrons are accelerated in emitter, then the current should be taken as IE. And when they are accelerated in base, IB. And when they are accelerated in collector, IC. That's what I read here. IE is equals to IB plus IC. And again, as usual, same thing. Emitter current must be greater than the collector current, and emitter current also greater than the IB. So this is the what you have to say. In case of NPN transistor, inside the transistor, the current is because of electrons. In case of PNP transistor, because of holes. Clear? Then what's happening? So when the XX electrons are reaches the collector, because collector is moderately doped, and base is the lightly doped and this is heavily doped. When already in case of collector already electrons are there, some excess electrons are coming, and again they should be repelled, and obviously they are attracted by the positive terminal of the battery like this. Positive terminal of the battery. Then obviously here again the electrons are loss of electrons. When the electrons are comes outside, then obviously the electrons are again refilled by the electrons which are coming from negative of the battery to the base again. And again in that some of the electrons are attracted by the positive. And again as usually the electrons must be sent to the base like this. Because of these electrons only, the electrons are repelled. That's why what we have to say, in case of NPN transistor, outside the circuit transistor also, electrons are the carriers of current. Simply in case of NPN transistor, inside the circuit and inside the transistor and outside the transistor, the current is because of electrons. Very simple. the electrons must be here attracted by the positive of the battery. The excess electrons which are coming from the collector, they should be attracted by the positive one, and again the electrons must be moves like this. So from that what you have to say? In case of NPN transistor, the electrons must be moves from inside in NPN transistor inside base collector junction and outside connected to the again base. That's why what you have to say, there is a lot of difference between PNP and NPN transistor. So dear children, this is simply about the what is a transistor and how many parts in a transistor and how they can be connected and what are the circuit symbols of PNP and NPN and what is the working of PNP and NPN transistors. So I think so. If you can understood this one, like, share, comment the video, and if you can really understand my concept, you have to share our channel to the friends also. Okay, thank you for watching.